Hi, this video is about the concentration of ions in solution. All right, so remember, ionic compounds are made from a metal and a nonmetal. And the metal will lose its electrons to form cations, and the nonmetal will gain electrons to form the anion. And so that's where we get the charged particles from. Anything that has a polyatomic ion in it would be an ionic compound, and that includes ammonium. So remember good old ammonium, it's the positive polyatomic ion. So anything that has ammonium in it, even though ammonium is not a metal, it is part of a polyatomic ion. So that would be a ionic compound, anything that has ammonium in it. Okay, so we have learned that if we have ions, this is the key right here, if we have ions in solution, then we have an electrolyte, something that can produce an electric current. And so we've seen that ionic solutes produce these ions in solution to make them electrolytes. And just to remember, we watched a little video animation about this in class, but this here is our sodium chloride crystal. It's our solid, so the sodium ions are the small gray dots and the bigger ones are the chloride ions. And these little red things that have the two white dots on them, that's a water molecule, H2O. And so they come in and that oxygen with a partial negative charge will attach to the sodium ions and kind of pull it away from the crystal. Now we got the sodium ions floating around in solution. And then the partially positive, the two hydrogens there, they'll attach themselves to that partially negative chloride ion and pull it out of the crystal until the crystal is totally pulled apart and it is dissolved. And so we've got all these ions floating around in solution, and that's what makes it an electrolyte. All right, so I want you to have that image and that picture in your mind of really how those ions got into solution. All right, now we want to know the concentration of the ions. When we talked about electrolytes before, we didn't know anything about molarity, but now we do. So we're going to try to combine these two concepts. So what is the molarity or the concentration of these ions in solution? All right, let's say that that was a 1 molar solution of sodium chloride, and that AQ there just means that it's an aqueous solution. Well, these square brackets, we haven't seen these before, and this is really important. Those square brackets mean molar concentration, or the molarity. And if you remember, molarity would be moles of our solute per liter of solution. So the sodium ion concentration would be 1 molar. So remember, the sodium chloride in solution is it's completely come apart, and we've got sodium ions and chloride ions. The sodium ions are 1 molar in concentration, and so are the chloride ions. I hope this makes sense. If it's 1 molar sodium chloride, then when it separates, the sodium ions are 1 molar and the chloride ions are 1 molar. All right, let's look at another ionic compound. This one is calcium nitrate, and so here we have a polyatomic ion. Well, polyatomic ions don't come apart, so this is an electrolyte, and we've got the calcium ions and we've got the nitrate ions. All right, so what is the concentration of those calcium ions? Well, it's 0.25 molar, so the calcium ions are 0.25 molar. But what about this 2? There are twice as many nitrates as there are calciums. So what do you think? Common sense, your chemistry sense. We've been in chemistry long enough that you've got some chemistry common sense, I like to call it, would say, well, the nitrate ions must be 2 times that concentration, and it is. It's 0.25 times the 2, so the nitrate ion concentrations are 0.5 molar. All right, let's try this one. Again, we've got sodium sulfate, and we have sodium ions in solution, and the anion that's floating around in there is sulfate. And we would like to know the concentrations, so we're going to put them in brackets. So what is the molar concentration of sodium. Well, it's a 0.5 molar solution of sodium sulfate, but we have 2 sodiums for every sulfate. And so the sodium ion concentration is 1 molar. That comes from the 0.5 times 2. The sulfate ion concentration, there is only 1 sulfate. That 4 is just part of the formula for sulfate, so don't use it at all. The sulfate ion concentration, there's only 1 sulfate for every 2 sodiums, so the sulfate ion concentration is the 0.5 molar. All right, now, we also learned that acids are electrolytes back in our electrolyte unit. And again, acids are things that make H+ ions in solution, and they also have the anion that accompanies that H+ ion. So for instance, hydrochloric acid in solution would have H+ ions and the chloride ions in solution. And the nitric acid would have the H+ ions. They're called hydronium ions sometimes, or just protons, and our nitrate ion. Okay, so acids are electrolytes, and they're electrolytes because, you know, they ionize. This H comes off of these acids. All right, well, strong acids completely ionize, just like those ionic salt solutions that we've been looking at. These acids completely ionize if they're strong acids. And at this point, I'll let you know if they're strong acids or not. Weak acids, however, they don't completely ionize. In other words, you know, not all of the H's come off. And so some of them do come off. There are just fewer ions in solution, so they're weaker electrolytes. Well, let's look at a problem where we have a strong acid, nitric acid. So what are the ions that are in solution? Well, all acids have H+ in solution, and here we have the nitrate as well. All right, it's a 0.5 molar solution. This strong acid completely comes apart. So the square brackets, meaning the molarity of the hydrogen ion, is 0.5 molar, and the nitrate ion is also 0.5 molar. Notice we have 1 nitrate ion. That 3 is part of the formula for nitrate, and we have 1 hydrogen ion. Okay, now what if we have a weak acid? So we have a 0.5 molar solution of, this is called acetic acid. And we know that these weak acids are weak electrolytes. So if it's a weak electrolyte, it doesn't have as many ions in solution. So it has some hydrogen ions and some acetate ions, but they are far, far, far less than 0.5 molar. If you would like to learn how to calculate the exact proton concentration of a weak acid, well, then you better take AP Chemistry, because that's a problem for AP Chemistry. But for right now, just know that the proton concentration and the acetate ion concentration in these weak acids are far less than the concentration of the acid. All right, so that's all. We're going to do some practice with this in class. Bye.